Alright, this video is for the Reflecting Quadratics practice for the Blended Algebra 2 class, Unit 5. Alright, so there's a lot of problems on this practice video. We'll start with 1a and 1b. We're going to write equations in vertex form of quadratics that have undergone the given transformations. So, first, and this is all no calculator, by the way. So no calculator, no Desmos allowed. We're going to reflect over the x-axis. If you look at your transformation charts that we filled in, reflecting across the x-axis happens when there's a negative in front of the equation. So what we're going to do here is put a negative before we do anything else. Shifting to the right happens inside the parentheses. When I go to the right, again, when I look at the transformation chart, going to the right is a minus inside the parenthesis with the number. So you would write minus 3, and then you have to put your squared at the top. For the next one, when you go across the y-axis, our chart reminds us that the negative is inside in front of the x. So you would write y equals parentheses negative x squared, and 5 units down would have a minus 5 on the end. Alright, the next one we're going to go over is number 6. It's a multiple choice. It says a reflection over the x-axis. After a reflection over the x-axis, that parabola would have what equation? So the first thing I would do is sketch the given parabola. I'm going to use pink here because I boxed it in a pink. X squared minus 4. Well, that's the parent function shifted down 4. So remember, our parent function, so if I start normally at the origin here, would be down 4. The pattern for the parent function we have to get really good at is out 1, up 1. Out 2, up 4. Out 3, up 9. So that's the original graph that they started with, x squared minus 4. Now what it says happens is it took that pink graph and it reflected it over the x-axis. So it flipped it over this line. So what you're going to do is you're going to take all of those points that we already plotted, and I'll darken them in. You're going to take all of those points and reflect them over the x-axis. So if I start at the vertex, if I'm 4 below the axis, I now want to be 4 above. The next 2 points, there's 3 below, so we want them to be 3 above. The x-intercepts stay the same, and the points that are 5 above become 5 below. Over here. So when we connect those, it makes that upside down parabola. Reflecting over the x-axis flips you upside down. So the equation of the purple has a vertex at 0, 4, and it's upside down. So we have a negative in front for being upside down. We didn't move left or right, so it's just x squared, and the vertex is up 4. So that equation would be C. Alright, the next one, number 7, we'll do A and B here for 7. List the transformations that occurred. Now, you need to still know the parent function. Remember, the parent function starts at the origin, out 1, up 1, out 2, up 4. So you need to know the shape of this parent function in order to figure out what transformations happened. Now, let's figure out. The graph is upside down. So we know that it reflected over the x-axis. Okay? The graph also looks like it went right 3, and then it went up 1, 2, 3, 4. So there were 3 transformations that happened to that graph. Now we want some multiple choice here. Choose the equation. Well, reflecting over the x-axis has the negative out in front, like we have in B and C. So I can cross off A and D because these do not show us the reflecting over the x-axis. Right 3 is a minus sign inside the parentheses, which I have right here. That's right. This plus 3 means you went to the left. And then up 4 is a plus on the end, which they both have. But because B has the correct negative, that would be the equation. Alright, number 8. This is similar to the last 2 problems on your notes. We're given an equation. That's the equation of the parabola that's already graphed for you. Vertex at -2, -4. We are going to reflect that parabola over the y-axis, which is this vertical axis here, and then we're going to write the new equation. So to start, you take each point and reflect them over the green line. So since this pink point is 1 to the right, I'm going to move it 1 to the left. The next point down here is 1 to the left. It's going to go over here to the right. The vertex is 2 to the left, so it goes over here. This point goes 4 over here. There. And this point's on the axis, so it stays put. So this should be your new parabola. Now, they want to know first the vertex. Well, that vertex is at 2, -4. That's going to help us write the equation in vertex form. The parabola is not upside down, so I don't have to put a negative sign anywhere. It's facing up. Having a vertex that went to the right, +2 here, will give me a -2 in the parentheses, squared, and then the same as the y value of the vertex. All right, and finally, number 9. I think this is the last one. Yep. We're going to find the vertex, state the transformations, and then make the graph of this problem. Well, our vertex, we use the number that's after the x in the parenthesis. There is no number, so that vertex is at 0, same as the y value at the outside of the parentheses. The transformations, well, when I have a negative inside the parentheses, here, that's reflecting over the y-axis. So this graph is going to reflect over the y-axis, and then the -6 means that you went down 6 units. Well, let's think about this. If I'm reflecting my parent function, which is graphed, over that green line, which is the y-axis, it's going to look the same. That is the axis of symmetry, so that's not going to change anything at all. So really all you have to do to this graph is move every point down 6. So when you do that, right here, you should get a parabola that looks like the purple one there. And that would be your equation. All right, if you have questions other than the ones on the video, you need to check the Can Canvas or ask your teacher for help.